All right, we're going to take a look at compression and tension in materials. So if you take a slab of material that's like represented by this red rectangle here, and you just set it on the ground, the material is supported at all points along its base. And so what's happening is the material is not really being squeezed along its length or pulled along its length at all. And so I've kind of represented that by these little springs that are kind of all the same length. So there's no force, horizontal force on this material. Well, if you only support the edges of the material, then of course right gravity will pull the center of the material down. And what ends up happening is the top part of the material kind of gets squeezed together. And so I've kind of indicated that as like a squish spring. And so the top part of the material is compressed and the bottom part of the material is sort of pulled apart. So the bottom part of the material is in tension. Well, if you go to make a bridge to go from, say, this side of the canyon to the other side of the canyon, just using a concrete slab or something might not be the best idea, because concrete is spectacular in compression, but it's not very good in tension. You don't want to be pulling apart on concrete. And so you can kind of see this effect here. I've got this piece of foam that's spanning the two tables here, and you can see it sagging down in the middle. Well, the effect is more pronounced if I sort of put a weight in the middle. These would be maybe people trying to walk across the bridge, and you can see the material is really compressed together at the top here under the weight, and then down here at the bottom the material would really be pulled apart. Well, so what we can do to help things out is if we had a material that was really good in tension, and so what I've done is I've taken another piece of foam here and put duct tape on one side. Well, duct tape is not great in compression, but it's pretty good in tension. It's got all these little fibers in it. And so what you can do is have the material set up so that duct tape is actually down at the bottom where we need it, where we need some help with the tension. So what we'll do is we'll put a passenger or put somebody on this bridge. And what you can see is that the bridge that has the duct tape on the bottom, the red part on the bottom, isn't sagging nearly as much, because we've put a material that's great at handling tension where it's needed the most. To really see this effect, if we put the duct tape on the top, which is not really where we need help with tension, you'll notice that sags down a little bit more than the bridge that has the duct tape on the bottom. And again, that's because the bottom of the bridge is in tension. And so to help with that, you could put the duct tape there, or the rebar if you're using a concrete bridge. So there's a little introduction to compression and tension and how you could deal with that with materials like concrete that are not so great in tension. You can add supportive materials like rebar, in this case symbolized by the duct tape, to help with the tension.